I have the pleasure of introducing Joanna Berg this morning. Joanna has worked in sterile processing for 35 years in the animal healthcare industry at K-State. She started at the teaching hospital and now she works in the diagnostic lab. She's a member of the Healthcare Sterile Processing Association and represents the Kansas chapter with the Kansas Society for Healthcare Central Service Professionals on the chapter committees. She has multiple trainings within the sterile processing profession, and she's provided input for the book, The World of Surgical Instruments for Animal Health. In 2023, she obtained her autoclave certification from Consolidated Sterilizer Systems, and she serves as the primary sterilization trainer for the Veterinary Diagnostic Lab at K-State, and she does education events for continuing education for KSH CSP. I'm moving.
The arrow keys.
Alrighty. Thank you, Rachel. I picked the title, The Dirty Secrets of Autoclave Success, because we all know we usually start out in the dirty world before it goes to the clean world. So our objectives are going to be some sterilization terminology, a little bit of brief history of autoclaves, how it works, safety hazards and PPE, cycles and indicators, validation versus verification, and documentation. So we're going to start with a few definitions. First definition is an autoclave is a machine that uses high pressure and high temperature steam to sterilize items. Validation is a method and practice of testing the parts and functions of your autoclave to make sure that they are performing their jobs as intended. And verification is the process that tests the autoclave process to identify any equipment or process failures. So a little bit of history here. The first attempt at sterilization was boiling instruments in 130 to 200 AD by Galen. In 1862, Pasteur developed pasteurization, and the word sterilization was introduced in 1847, but didn't appear in literature until 1877. Then Dennis Papin in 1680 and came up with a digester, which is this little picture here, which is actually the precursor to the autoclave. Then in 1880, Charles Chamberlain developed the first steam pressure autoclave, which is in this picture to your left, along with his picture. It looks more like a pressure cooker and only went to 110 degrees Celsius. So here's a picture of closer to a more modern day sterilizer. If you notice, this door here actually has arms that go out into it, which is just a little bit older because most of the ones that we currently have now, you actually can either do a foot pedal or you can raise them up and they will lock in place and will not allow you to start the sterilizer unless it is sealed. So some autoclave uses in the healthcare world. You sterilize surgical instruments. That also is so in the dental and veterinary instrument area. You'll have equipment like saws and drills and etc. like that you would do. In the laboratory, we're sterilizing instruments, glassware, media, or liquids. You can decontaminate biohazardous waste, bagged and tagged as we do it in our world. In the food industry, it's used for things like mushrooms. In the pharmaceutical industry, they sterilize pharma products. Most of those are actually compounded. And aeronautical, it's a cured composite for rosin and testing. And in electronics, it actually produces a synthetic quartz crystal. So how our autoclave works. by killing the microorganisms and spores using a combination of steam, pressure, and time. Steam moisture transfers heat to items, destroying the protein structures of bacteria and spores. And I like my little animated guys there. So the sterilization phases. Conditioning phase is the step in the process where the air is removed from the autoclave chamber and expelled through the drain. If you take a look at this picture, you'll notice the air is going out there with those blue arrows. That is actually where your drain is located, and the steam is actually coming in the back. So that drain is actually your coldest area of the autoclave, which is the hardest place to test. So during the exposure phase, the items are held at a fixed temperature for a set amount of time. So what you actually see there is where you have the steam coming in, and the steam is actually getting to all the products within the load. If it can't get to it, it can't sterilize it. So therefore, we actually need even airflow. So in the exhaust phase, the sterilizer drain actually opens, and it allows the steam to get pushed out by the air that's coming into the autoclave and removing it from the chamber. So some safety hazards. You have burns from physical contact with the autoclave or from steam burns. You have glass breakage because glass vessels can break explosively when opening and closing the autoclave due to the temperature change, because you're going from 121 degrees basically down to room temperature. If you do it too quickly, that's where your explosion is going to come. So what you're going to have to do is just open your door slightly and give it a little bit of time to cool, about 5 to 10 minutes. So our safety PPE requirements: the buttoned lab coat, closed-toed shoes, safety glasses, heat resistant gloves. And if you have long hair, it is very much suggested that you kind of contain that long hair back in some form or fashion. So you're loading and unloading. So when you place your items into your racks or trays, you do not want to stack anything. This is one of the worst offenders I actually see in my building, is they tend to stack, especially pipette tips. So that's one thing I tell them. I says, you can't stack those guys together. You stack them together. Any place you have contact, that is where you're not going to actually get sterile. That is going to remain basically contaminated. So we want to leave 1 to 2 inches between our items. You want to always place your items into secondary containers, whether it be metal or Nalgene. And I know some of our vendors out here today actually do sell these. Label your package, whether it's a self-sealed pouch, bottles, even if it's a biohazard trash bag for some reason. Let's say we have something we have to put in there into a biohazard trash bag, because it is a reusable thing. So we're going to put it in our bag. You always need to put a piece of autoclave tape on the outside of that bag so that you can prove that it has actually been through the sterilizer. What we do with a lot of our items like that out in the diagnostic lab is we'll take a chemical indicator and a biological indicator, tie them on a string, drop them down into the bag, but leave part of that string out there, hanging out of the bag with a 1 inch opening in the top of the bag. So if that steam can't get through into the top of the bag, it cannot get to the items in that bag to actually do a kill. Okay, so we're always going to wear our PPE. That's always a necessary must. You want to place a test pack that has a CI and a BI in it into your load, whether it's in your rack or on a tray. You're going to close your autoclave door. You're going to select your cycle. Cycles have different times. They can also have different temperatures, depending on what that cycle is set for. So upon completion, you're going to open the door a crack. By a crack, I'm saying probably 5 to 10 inches. You want to let it set. That's going to help you have your items inside cool down a little bit to that room temperature so you do not have explosions. Then you're going to remove your rack and remove your test pack. Some types of cycles: gravity cycles, which is a more common one for most of the laboratory setting. The sterilizer heats the water, turns it into steam. The steam pushes the air out of the autoclave through the autoclave chamber and down the drain. So this is passive air removal. And an exhaust cycle has a fast exhaust. Liquids used for media and broth are non-flammable liquids or pathological body parts. Liquids actually have a slow exhaust. And the reason being for that is if you have liquids in bottles, and if you have a fast exhaust, it's going to suck everything out of your bottles. So you're not going to have any sterile water. You're not going to have any media. You're not going to have any broth. It's all going to get sucked out. It's all going to go inside that autoclave. That's why you need a secondary container. And then there's a pre-vac cycle. So the sterilizer is going to heat the water and it's going to turn it into steam. It's going to use a vacuum pump to quickly remove the air from the chamber. So the quick cycle, this is a dynamic air removal. So due to the use of the pump though, you need to do an air removal test. This is a buoy deck. And basically a buoy deck is like a class 2 indicator. Excuse me. So it's basically like having a stack of index cards and you have a card in the middle of that stack that actually has a die pack that has to explode. And if you don't have air removal throughout your entire machine, you're going to have spots because this will start out white. Those spots will show up yellow. But if it truly passes, you're either going to see blue or black depending on who your manufacturer is. It's almost kind of like a little maze within the card system that you will actually see that's going to test your air removal within your machine. So some basic parameters: your temperatures can range from 121 to 134 degrees Celsius or 250 to 275. Your pressure in the chamber is always going to be at 15 PSI. Your cycle times, most of them are recommended at a half hour. There are some shorter ones, which is a little more common in healthcare than it is on the laboratory side. And with exhaust rates for dry materials, it's going to be fast. For liquids, it's going to be slow. So some quality assurance. Chemical indicators, and this is from ANSI AMI ISO 11140-1 2014. The type 1 indicator is a single parameter indicator, meaning it's either been exposed to heat or it has not. This is your autoclave tape. Class 2 and 3 are an inside multi-parameter indicator for air removal or temperature, but it won't do both. It will do one or the other. So, and internal indicators require multi-parameters of time, temperature, and pressure. So that would, then your class 4 is a multi-parameter that tests for temperature and time. The only one you're going to get a full test on is a class 5, and that's actually a chemical integrator. And that one is designed to react to all 3 of the critical parameters of time, temperature, and pressure. So some CI types. Class 1, here's a picture of your autoclave tape that you put on the outside of bags. You can even put that on the outside of self-seal pouches if they do not have a built-in chemical indicator. This picture here is a Getting product. This one is actually a class 5 integrator. Here is a picture of the biological indicators. You notice they have a nice little lovely purple tinge to them. And there's a blue line on there that actually will turn when that is exposed. So we're going to delve into the world of biological indicators a little bit here. Their purpose is to prove sterility and function. So you have product as your product and your autoclave. That's what you're needing to prove sterility and function on. So in the process, the BI contains the Geobacillus spore. because it's the hardest spore to kill during autoclaving. Positive growth. You've seen that on that, there is actually purple media within that. So that purple media is what it starts out to be. We pass these around. If you take a look at these biologicals that are coming around the room, you notice that the media in there is purple, and you're going to see a little purple strip. That purple strip is where the spores live, and that media just acts as the carrier. So you have the tube, the media, the spore strip, and you have your cap. That's the components that actually make up your biological. So if I run that through an autoclave and I incubate it, it needs to come back that same color. If it comes back yellow, then you have growth. So then you have bacteria and little spores growing. That is where you run into a problem, which you do not have a product that has a terminal kill or terminal sterilization, depending on which you are trying to do. So within our little world, within the VDL, we actually run one of these with every single load. So if you actually have a failed BI, you're going to take your autoclave out of service and have your technician come in and check your autoclave to make sure that all your valves and everything are all functioning properly before you put it back into service. And then you're going to take and you're going to run it with 3 BIs and for 3 runs until they pass to make sure that you actually have a kill. Okay. So validation versus verification. Validation is the process that confirms an autoclave is working properly and can sterilize equipment and supplies safely and effectively. So in simple terms, autoclave validation is a method and practice of testing the parts and the function of your autoclave to ensure it is performing the job it is intended to do. So, what does steam sterilization require for validation? You have critical factors where you have to have calibration of temperature sensors, which is essential to the operation and can demonstrate that the sensors are within an acceptable, accurate range. Equilibrium time is the time that it takes all the probes to reach the set temperature. Lag time is the time it takes from probe number 1 to probe number 2 to reach the set temperature, which most commonly is 121 degrees Celsius. So acceptance criteria is uniform distribution and penetration of the heat in the load for the duration of the sterilization hold time. The hold time is the time it is required to actually get a sterilization or a terminal kill. And the temperature has to reach that in the mapping with mapping probes during the complete cycle. So if I'm running a 30-minute cycle, that's supposed to be my 30 minutes of kill time from probe 1 to the last probe for that solid 30 minutes, it has to stay at that 121 degrees. Most of the time, this process is actually done in the manufacturing plant prior to leaving. But if you're having a large scale install, this would be more common in big manufacturers, say like Beck and Dickinson. It can be done at our level, but it becomes a little costly. Okay, so these 2 little boxes here, these dots actually represent where temperature and mapping probes would be within these. You can run anywhere from 9 probes to 20 probes, depending on your chamber size and how exact it needs to be for what you are trying to do. So if you look at the dots in this picture, this is a temperature mapping that WHO has set the recommendations for. They have their outside, their middle, and their bottom. And you notice that the number of dots are not the same for the top and the middle, but they're more similar for bottom and top. So what does all this end up with when we validate a cycle? And you have to validate every cycle. So if your autoclave has 5 cycles, that's 5 validations. An average validation on a cycle takes anywhere between 2 and 4 hours to do. And this isn't something that we can do ourselves. It's actually, you have to get a manufacturer or someone trained to do it, to come in and do it. So validation is a high dollar cost thing. So we're going to move on to autoclave verification. It's a documented procedures performed in the use environment to obtain, record, and interpret results required and establish predetermined specifications that have been met. This is directly out of AMI, ST 79, section 228. So the frequency depends on your usage factor. So if you have a daily usage, your minimum is going to be once a week or bi-weekly. If it's less, like say use it maybe 1-2 days a week or every other week, then you can move on to a month to do this. So materials that you will need is for the type of load, whether it be liquids, plastic tips, etc., depending on what you have, or whether you're doing waste loads. You must verify every load, with waste loads especially, because you have to protect the workers, you have to protect the environment. Preventative maintenance should be done by your original equipment manufacturer. Some places will use third party and some people will actually use biomeds. Okay. Verification, what's involved? Measuring steam pressure and temperature during the sterilization cycle. Testing to confirm the autoclave is reaching the required temperature. Checking the functionality of safety features and control systems and documenting test results. So our methods of testing efficacy of your autoclave. The physical ones are actually the pressure and temperature recording device, which could be something as physical as what this gauge is. This is actually a printout from the autoclave, which is in that little packet that you had, because I wasn't sure how well this was gonna pop up on there. But if you notice on the left-hand side of that, as you look down there, you're gonna see where it prints out the C's, which is actually the condition phase. That is where the autoclave is actually conditioning itself. It's pushing all the air out and pulling all the steam in. So that's where it's conditioning itself to get up to the temperature it needs to have. And then in that orange section, we're actually changing to where we are starting the sterilization phase. All the time that is in the S phase, that is the sterilization phase. So that's the time that that machine has set for, we have to have this amount of time, depending on what we're sterilizing, to make a sterile product. Then you have E, that's your exhaust phase. That's where all the steam is getting pushed out by the air coming into the autoclave. And on this particular tape here, you see the letter Z. That will show up when your cycle is actually complete. At that point in time, it is telling you exactly what has happened in your autoclave once you reach that. Okay. So your chemical indicators are actually going to have a color change after exposure. The top one is a brand new one. The one below it is one that has been exposed. And if you notice in that window there, there's in that blue area, that's the pass fail area. Once it's into that blue, technically, because this is set by each manufacturer, not by anyone's standards or anything. Each manufacturer sets this. Since that blue is actually into the blue area, it's technically considered a passed chemical indicator. Okay. And here we see our positive and negative biological side by side. That yellow one is actually growing. So if you have one like that coming out after it's been autoclaved and after it's been incubated, then you have to kill that biological. So you still have to run that biological through once you know that your machine is functioning properly. Okay. So how do we verify sterilization? You run 3 consecutive loads with the BI and CI in a test pack. And you put this in your tray or rack, depending on whichever you have. You're going to run 1 test pack for each cycle that you use, and you need to test each cycle separately. So if you have 5 cycles in your autoclave, you're testing each and every cycle. And how to verify sterilization has occurred. The spore testing provides a reliable method of sterility assurance. Spores used in the autoclave are the Geobacillus rhamnophilus. It's used because it's most resistant microorganism and it's hard to kill. There's a picture of our little friends that live on the paper in the tubes. So, build a test pack, which you guys in the room are actually going to have a little bit of an opportunity here to do that. So your materials are going to be your biological indicator, your chemical indicator. We're going to use self-seal pouches today, but you can do this with autoclave bags. You either have to use, as far as writing on them, an industrial Sharpie or an approved sterilizer marker. So on the biological, what we would take and do as far as writing on those, we would actually put the date, the load number, the autoclave number, and our initials on there. So you're going to open your self-seal pouch at the bottom. You're going to slide a chemical indicator and a biological indicator into the pouch. You're going to seal it, and then it's ready to place in your load. So here is a test pack placement picture. So after you have your test pack ready, you're going to load it into your tray or rack. When you put your rack or tray into the autoclave, you have to pay attention to where your drain is, because the drain is the coldest spot in that autoclave. That test pack needs to be directly over that drain, because otherwise you may get hot and cold, because actually setting inside of the autoclave as these things are going through with bags and pouches, they will actually open and close like you have a bellows open and close, moving apart from each other. That happens the entire time these things are in sterilization. So you can also have some, if you get them in too tight of a package, that will actually rupture the package. So we're going to place our test pack directly over our drain, since that's the coldest spot. So we've run our load with our test pack in. So now it's time to unload our autoclave. So the cycle ends. Most of the newer ones, you'll have a buzzing sound. I like the ones I have out in Mosier, because those you actually get a bright screen touchscreen, and it will stay up once the buzzer has quit sounding. So you're going to open your autoclave door slightly, so about 5 inches. You want to stand off to the side, because not necessarily is all that steam going to get out by going through the drain. Part of it may come out and go up if your door comes up and down. If you have a door that opens sideways, hit your button or your foot pedal and stand off to the side away from the hinge door. We don't want the door to smack you. So we're going to let that sit for about 10 minutes before we open it the rest of the way and give it a little bit of cool down time. You're going to remove your load while we're wearing your PPE. You're going to remove your test pack and set it aside, and it needs 10 minutes to cool down, because these little biologicals, If you take them while they're still hot and put them in the crack well of an incubator and crack them, they will act like a missile. That cap will fly off, that media and that strip will fly out of there. So then you have no way of testing the verification on your load. So guess what? You get to run it all over once again, so that you actually have a test pack. Okay. So after that 10 minutes and you remove your pack, you're gonna check your CI for a color change. So how far across did it go? Did it get into the pass range? Is into the pass range? You're good. Then you're gonna take your BI. You're gonna set it in your incubator. Most incubators have a crack well. So they're basically about a 5-inch by 5-inch block, and you're gonna have an oblong one in there that you're gonna set your biological down, you're gonna lean it over, it's gonna crack, and you will hear it crack. And then you can just take and set it in a well. Well, then you need to start recording things like your time and stuff on a log. So once you place it in the incubator in that slot, and you have to do this according to the instructions for use for the biological, because not every biological is the same. So you're going to log your information on your BI log sheet, and you're going to read at the time for your BI per your IFU. Not every biological has the same readout time. If you want to spend high dollars, you can have a readout in 24 minutes. Most people stick with a traditional where you read it at 10 hours and you can come back and check it again at 20, and you need to record your results. So on your BI log, and if you look in that packet, there are some different examples of load log sheets and biological load sheets. You're going to put your sterilizer number on there, the date it went in the sterilizer, the load number for the day, your initials so that you know who ran it, the date and time your biological is placed in the incubator, and you're going to have a read time. We read ours, because of the ones we use, twice a day at 10 and 20 hours. And we initial after each one of those readings on our log sheet. You need the BI lot number on there, the expiration date. And if you notice on that biological load run, there's actually a box to check whether or not you have a rerun. Because if you have a rerun, you need to reprocess your items. And that's usually when you have failures. Okay, here is another thing on the printout, which we kind of hit previously with the conditioned, sterilized, and exposure phases. So since we need time, temperature, and steam, because our end goal is to have all three of these guys. We need them all to get where we're going. Here's our little critters running around inside of whether it be our biohazard bags or in our pouches with instruments. Here's our little critters. This is what we need to achieve. We need to kill any little critters that are in there. There is a set of references there. Okay, for those of you that are actually here in the room, our vendors have donated some pouches and stuff. So if you guys want to come up this way, we're gonna build the test pack. And this is actually kind of the way EH&S is gearing to make everybody do verification. So if someone would please bring those two back there up this way on their way by, those two biologicals there on the table. We're gonna build some test packs right quick. Way back. Okay. Come on, kids, let's be active participants. Come on, come on. And I know that those of you that are not in here cannot see us, so what we're doing is we are taking some small self-seal pouches. And we are using a chemical indicator. This one is actually a class 4. This is one of Proper's. So we're sliding this into our pouch. And then we're taking a biological and sliding this into the pouch. And at this point in time, you would take your little strip off here at the bottom of your pouch, fold that over, take your fingers in the middle and slide going out. And the reason you want to slide from the middle going out is you need to make sure that you're getting all of the air out of that pouch, its bottom seal, so nothing can creep in the bottom. Because even air coming in the bottom of that pouch can affect your results of your BI. This is what you would take and actually put into the middle of your rack or tray right over the drain, since that's the coldest spot. So this would go through the autoclave, through your cycle. You would take it out, let it set 10 minutes. If that media in there is going to be hot, we don't want an explosion. It is fun to watch, though, I will say that, because I've actually seen that happen. And you'll take him, you'll place him in the little incubator that's like 4.5, 5-inch square. You put him in there, you bend him over in the crack well, and then you'll send him down in to one of the wells to actually incubate for 10 to 20 hours and record your results.
A question. I don't do chemical, I
Mhm.
only do biological. Is it necessary to use this pouch or can I just put the strip? on it?
You need to have a way to contain both your chemical indicator and your biological indicator. So if you don't want to use a pouch, then use a small biohazard bag, but make sure you leave 2 fingers worth of space in the top and put a piece of autoclave tape on the outside. But you can use the twist ties that come with the biohazard bags. Yeah, you can use those. Just don't ever choke them down tight or use a zip tie. Because if steam can't get in, the steam can't do a kill.
So is it incorrect in your opinion? That I'm not using these, I'm using this strip of bacillus. So or even the same brand, they're just different.
Okay.
So is it incorrect to just put the open strip in my tab where I have to play?
Everything that I've ever seen and read, you know, you're not supposed to put your strip straight in there. You
So
need to,
you
you
need-
need to either pouch it or bag it. You're welcome.
Just another question I have.
Yeah.
I'm in chemical engineering and a lot of parallels between an autoclave and a reactor.
Mhm.
So we're bringing the temperature up, we're bringing the pressure up, and we're giving it time. Is there anything you've ever put in an autoclave and opened up the door and there's some sort of gas or something that came out that you're like, I know that probably shouldn't happen, like, or any common substances that might be residual on instruments that you would recommend not sticking in an autoclave?
I've never seen it in a gaseous form. I have seen where people have run liquids through an autoclave and then run a hard goods load right behind it. Liquids goods tend to leave a film within the autoclave, so that film actually will pick up on these pouches. And if you're doing glassware where you're just covering it with foil and using one of these and just taking it in, basically bending it over like that to hook on there. And then putting your foil on top of there with a piece of autoclave tape. I have seen it adhere to the outside of the glassware. Well. So you have then you have a product that's not usable.
I guess I've also heard some horror stories about bleach in autoclaves.
Yes. Which in autoclaves is a huge no-no because it can become very volatile and it will actually eat the inside of a sterilizer. Because as we move more and more modern sterilizers. The newer ones are all made out of 300 and 400 grade surgical stainless steel inside. So you have to be extremely careful what you can even clean them with nowadays. So like, because the newer ones that we have out in Mosier are the 300 grade surgical stainless steel. And the only thing we can use to clean those with is distilled water. Same way with the iPad touch panel on the front. They get something on it, then we have to use microfiber towels and distilled water. That's why every year they go back through autoclave training. Anybody who uses those autoclaves within the department, whether it's the BDL people, the DMP people, the clinical science people, they're going back through training yearly, starting January 1st. Because there are some issues out there, and safety has actually, within our facility, has actually asked that we do this.
So I guess that kind of leads me to another question.
Okay.
Is it a cost loss if I mess up my autoclave validation? Or is it mainly a time loss because I'd have to run the cycle again, or a little bit of both?
Well, it depends on, because depending on what your product is that you have in there is what it's gonna affect, because if it's something that's supposed to be a clean product inside and out, then you're gonna have to take it all the way back through the cleaning process and start over from step one. So yeah, you're wasting money, you're wasting time. But then you're also, if you have to do this multiple, you're also wasting product there. Any more questions? Okay, well, if not, then thank you.
Thank you.
Thank you.